Human Impact on Oceans Part 2. I can recognize human dependence on ocean systems and explain how human activities have modified these systems. Modifying ocean systems. Humans depend on the ocean for a variety of resources. We depend on the ocean for water. Desalination of the ocean provides a source of fresh water. Food. We harvest marine organisms for food. Some parts of the ocean is used as commercial fisheries. Some ocean organisms, such as algae and seaweed, are used in the manufacture of food. We depend on the ocean for transportation. The ocean is used to transport items from continent to continent. We depend on the ocean for recreation. Ocean recreation includes boating, swimming, and surfing. We depend on the ocean for oxygen. Ocean autotrophs provide us with oxygen. We depend on the ocean for natural resources. Oil, gas, minerals are derived from the ocean. In the process of using ocean resources, we have modified, changed the ocean. For each, use the ocean, select the true and false statement. Water. Desalination of the ocean provides a freshwater source. This is true. Food. Some parts of the ocean are used for commercial fisheries. This is true. Transportation. Okay, the ocean is used to transport items from continent to continent. And natural resources. Natural resources include oil, gas, and minerals. This is true. Pollution. Let's read the paragraph and then answer questions on slide 5. The ocean absorbs a great amount of carbon dioxide and pollutants. Large amounts of pollutants in runoff drain into the ocean daily, killing marine life, threatening human health, causing toxic algae blooms, and forces beach closures. Human pollution is destroying coral reefs and coastal habitat, which are vital for breeding, food, and shelter for marine organisms. Let's watch the video on pollution and then answer these questions.
Do you ever think about how important the oceans are in our daily lives? The oceans cover 2/3 of our planet. They provide half the oxygen we breathe, they moderate our climate, and they provide jobs and medicine and food, including 20% of protein to feed the entire world population. Now, people used to think that the oceans were so vast that they wouldn't be affected by human activities. Well, today I'm going to tell you about a serious reality that is changing our oceans, called ocean acidification, or the evil twin of climate change. Did you know that the oceans have absorbed 25% of all of the carbon dioxide that we have emitted to the atmosphere? Now, this is just another great service provided by the oceans, since carbon dioxide is one of the greenhouse gases that's causing climate change. But as we keep pumping more and more and more carbon dioxide into the atmosphere, more is dissolving into the oceans. And this is what's changing our ocean chemistry. When carbon dioxide dissolves in seawater, it undergoes a number of chemical reactions. Now, lucky for you, I don't have time to get into the details of the chemistry for today, but I'll tell you, as more carbon dioxide enters the ocean, the seawater pH goes down. And this basically means that there is an increase in ocean acidity. And this whole process is called ocean acidification, and it's happening alongside climate change. Scientists have been monitoring ocean acidification for over 2 decades. This figure is an important time series in Hawaii, and the top line shows a steadily increasing concentrations of carbon dioxide, or CO2 gas, in the atmosphere. And this is directly as a result of human activities. The line underneath shows the increasing concentrations of carbon dioxide that is dissolved in the surface of the ocean, which you can see is increasing at the same rate as carbon dioxide in the atmosphere since measurements began. The line on the bottom then shows the change in chemistry. As more carbon dioxide has entered the ocean, the seawater pH has gone down, which basically means there has been an increase in ocean acidity. Now in Ireland, scientists are also monitoring ocean acidification, scientists at the Marine Institute and NUI Galway, and we too are seeing acidification at the same rate as these main ocean time series sites around the world. So it's happening right at our doorstep. Now I'd like to give you an example of just how we collect our data to monitor a changing ocean. Well, firstly, we collect a lot of our samples in the middle of winter. So as you can imagine, in the North Atlantic, we get hit with some seriously stormy conditions. So not for any of you who get a little motion sickness, but we are collecting some very valuable data. So we lower this instrument over the side of the ship, and there are sensors that are mounted on the bottom that can tell us information about the surrounding water, such as temperature or dissolved oxygen. And then we can collect our seawater samples in these large bottles. So we start at the bottom, which can be over 4 kilometers deep, just off our continental shelf, and we take samples at regular intervals right up to the surface. We take the seawater back on the deck, and then we can either analyze them on the ship or back in the laboratory for the different chemical parameters. But why should we care? How is ocean acidification going to affect all of us? Well, here are the worrying facts. There has already been an increase in ocean acidity of 26% since pre-industrial times, which is directly due to human activities. Unless we can start slowing down our carbon dioxide emissions, we're expecting an increase in ocean acidity of 170% by the end of this century. I mean, this is within our children's lifetime. This rate of acidification is 10 times faster than any acidification in our oceans for over 55 million years. So our marine life has never, ever experienced such a fast rate of change before. So we literally could not know how they're going to cope. Now, there was a natural acidification event millions of years ago, which was much slower than what we're seeing today. And this coincided with a mass extinction of many marine species. So is that what we're headed for? Well, maybe. Studies are showing, well, some species are actually doing quite well, but many are showing a negative response. One of the big concerns is as ocean acidity increases, concentration of carbonate ions in seawater decrease. Now, these ions are basically the building blocks for many marine species to make their shells. For example, crabs, or mussels, oysters. Another example are corals. They also need these carbonate ions in seawater to make their coral structure in order to build coral reefs. As ocean acidity increases and the concentration of carbonate ions decrease, these species first find it more difficult to make their shells, and at even lower levels, they can actually begin to dissolve. This here is a pteropod. It's called a sea butterfly, and it's an important food source in the ocean for many species, from krill to salmon, right up to whales. The shell of the pteropod was placed into seawater at a pH that we're expecting by the end of this century. After only 45 days, at this very realistic pH, you can see the shell has almost completely dissolved. So ocean acidification could affect right up through the food chain and right onto our dinner plates. I mean, who here likes shellfish? Or salmon? Or many other fish species whose food source in the ocean could be affected. These are cold water corals. And did you know we actually have cold water corals in Irish waters just off our continental shelf? And they support rich biodiversity, including some very important fisheries. It's projected that by the end of this century, 70% of all known cold water corals in the entire ocean will be surrounded by seawater that is dissolving their coral structure. The last example I have are these healthy tropical corals. They were placed in seawater at a pH we're expecting by the year 2100. After 6 months, the coral has almost completely dissolved. Now, coral reefs support 25% of all marine life in the entire ocean. All marine life. So you can see ocean acidification is a global threat. I have an 8-month-old baby boy. Unless we start now to slow this down, I dread to think what our oceans will look like when he's a grown man. We will see acidification. We have already put too much carbon dioxide into the atmosphere. But we can slow this down. We can prevent the worst case scenario. The only way of doing that is by reducing our carbon dioxide emissions. This is important for both you and I, for industry, for governments. We need to work together, slow down global warming, slow down ocean acidification, and help to maintain a healthy ocean and a healthy planet for our generation and for generations to come.
Okay, so what is causing ocean acidification? Okay, that's human activity with the increase of carbon dioxide emissions. Does ocean acidification have a negative or a positive effect on the ocean? It has a negative effect on marine organisms and the food chain. What is a possible solution to decrease carbon emissions? Plastic debris and nets. Let's read the paragraph to answer the questions on slide 7. Wildlife is dying from litter and uncontained trash improperly discarded by humans. Of the approximately 7 billion tons of litter that enters the world's ocean each year, about 60% of its plastic composition. These items can last for about 10 to 20 years before finally decomposing. It's estimated that 1 million seabirds and 100,000 other marine animals, including endangered species, die as a result of having swallowed plastic litter or having been caught in it. Lost and discarded fishing lines and net cause terrible wounds and suffocation of sea animals. Okay, let's watch the video on plastic debris and nets to answer questions 8, 9, and 10.
Hi, I'm Carl Azouz. Great to have you watching CNN 10 today. This special edition of our show dives into an ocean of plastic, masses of waste accumulating on and around some remote islands in the Pacific. Synthetic plastic, the kind made by people, has been around since 1907, and scientists estimate that almost every piece of it made since then still exists. Why? It doesn't break down quickly in the environment, and researchers say that tons of plastic trash around the world find a way to leak into the ocean every year. It might be picked up on the coast and swept out to sea. It might find its way from streets to storm drains, carried by rivers to the ocean. And you're about to see its impact. Before we get to the problem, though, what can be done about this? It's unlikely and probably unaffordable to take plastics out of the environment altogether. But on a personal scale, people can reduce the amount of plastics they use. Think water filter bottles or jugs instead of throwaway water bottles. Think reusable fabric shopping bags instead of plastic ones. Think reusable steel drink bottles instead of single-use plastic cups. And when it comes to the plastic you do use and need to throw away, think recycling every time. This will help keep the materials from slipping into the environment. One image that's hard to forget about how plastic can impact the environment is what you can see in the stomach of a dead bird on a Pacific island.
Every time you throw away a piece of plastic, it can be felt here in paradise. This is Midway Island in the Pacific Ocean, one of the most remote places on the planet, but one of the hardest hit by pollution. But it's too late for parts of it. Your coffee cup, water bottle, toothbrush, they may all float miles to end up on these shores, inside these birds, the blubber of these seals, in the sand, and invisibly in the waves these dolphins call home. And eventually, these plastics may well end up inside you. CNN gained rare access to the island to see the toll of plastic you throw away every day and what that might mean for your body. Halfway between North America and Asia, Midway Atoll is one of the most remote places on the planet. It's 5 miles across, but has over 500,000 acres of submerged reef, every inch of which is controlled by strict federal law. We could only fly on a charter jet from Honolulu.
Well, it looks extremely beautiful and tranquil from up here, the Pacific at sundown, but across the world's oceans there thought to be some 5 trillion pieces of plastic just floating as garbage. And it's taken us months to make this journey out to Midway, slap in the middle of North Pacific Gyre, what's thought to be the biggest garbage patch in the world's oceans at the moment.
The jet can only land at night to avoid hitting the birds who swarm the skies in daylight. The Laysan albatross, its main resident, their growing chicks starting to fly. Yet something very unnatural is happening here.
Dawn lets you see just how unbelievably beautiful this place is. So pristine here, you almost don't want to touch it or disturb it. This is a rock that came out of the ocean 25 million years ago, but the tide has left a line of trash all along the beach here, pretty much as far as your eye can see. And it's amazing in the kind of detail too, of the things you find. Like a plastic mannequin's head. If it rained in a city far away from here for a few minutes, maybe somebody bought themselves a plastic umbrella for a quarter of an hour.
Just remember, none of this was used or brought here. It floated here for thousands of miles over months. We're 1,300 miles from the nearest city.
Everything that you see on top of the sand is a real recent introduction.
Matt Brown, with the US Fish and Wildlife Service, lived here for years and is our guide. And it is astonishing how they never stop cleaning up here. This just the last few years' worth, stacked on the runway, waiting for a ship to take it away. That umbrella, bottle or shoe all start off here in a city, let's say in Asia, where most of the plastic in the ocean originates from. You use it for a minute or two, but it joins the waterways, takes decades to break down, maybe longer. Much of it joins the Great Pacific Garbage Patch and spins endlessly, caught in the ocean currents of the North Pacific Gyre. The patch isn't easy to see, often an almost invisible soup of tiny particles made when larger bits of plastic break down. Pound for pound, by 2050, there will be more plastic in the ocean than fish. Midway is right on its edge, a rare place from which you can peer into it.
Okay, so what is causing seabirds, marine animals, and endangered species to die? So it's going to be plastic debris and nets. What are microplastic? Tiny pieces of plastic. What are the problems of microplastics? Okay, they act like a sponge for other toxins, and marine animals cannot break them down. So today, for your exit, you have an Ed puzzle on the Great Pacific Garbage Patch.